वॉइस नहीं आ रहा है.
Is my screen visible to all of you?
Yes, yes, everything is okay.
Hello?
Yes, everything is okay.
Okay. So a very good afternoon to all of you. Today my presentation topic is breakdown and flashover test for AC, DC and the impulse voltages. So these are the contents of my presentation, that is the testing. Actually, why do we need to do the testing? That I'll discuss. And after the types of high voltage testing, and then I'll discuss about the breakdown and the flashover test. So under this, we'll discuss the for all breakdown and flashover test for the alternating voltages, for direct voltages, for impulse voltages, and after that, at the end of the presentation, I have included some examples. That is a test on the solid dielectric sample and the test on the transformer. So why do we need to do the testing? As we know that we need to transmit a bulk of power, and that for that we need the high voltage system. For the high voltage system to transmit this bulk power, we need the high equipments to sustain that any abnormal condition or any over voltages. So that's why we need to test the insulating system so that it can sustain those abnormal situations or those over voltages. So the high voltage testing is generally carried out on a specimen or insulating material, or it can be carried out on a complete system as a whole. So high voltage testing can be categorized as according to the routine test, type test, and the spatial test. So what is the difference in between these tests? So routine tests are generally carried out on each and every insulating unit. These are like, I can give an example of like 1 minute power frequency test. That power frequency voltage will be applied on the particular insulating unit for 1 minute. If it sustains that voltage, if it withstands that voltage, then it will pass the result. Otherwise, it will not pass. Then we come to the type test. Type tests are actually done according to the customer requirement. Like if they need some specific requirements, then the manufacturer do that particular test. And then we categorize it into the type test. Then comes the spatial test. Spatial tests are done for the extreme conditions. Like if we are placing the insulating unit in under extreme weather conditions, under extreme temperature condition. So manufacturer does these spatial tests to check whether the insulating unit sustain the withstand voltage or not. After that, we can categorize our high voltage testing into the destructive testing and the non-destructive testing. The very basic example of the destructive testing is the breakdown testing. In this case, the sample get damaged and it can't be reused again. In the case of the non-destructive testing, we try to see the specimen performance or the dielectric sample performance without damaging it. So we can have one basic example of the PEA. PEA is like pulse electroacoustic method. So in that we measure the space charge accumulation in the dielectric sample without damaging the specimen itself. Later on, we can categorize the high voltage testing under according to the type of voltage. Like if we are applying the alternating voltages, we are applying the direct voltage, or we are applying the impulse voltage. Under the impulse voltage, we can categorize it according to the lightning or the switching. Lightning is a natural phenomenon, and for this we need to test our insulation. Like if it can withstand, but we need to design our insulating system such that it can sustain the lightning over voltages. So I'll discuss about the breakdown of flashover voltage under this category, that according to the type of over voltages. So breakdown of flashover test. Breakdown, before discussing the breakdown, let's say we are having two types of insulating system. Insulation, like one is the self-storing insulation and another is the non-self-storing insulation. So for the breakdown, as Dr. Alok has already discussed about the solid, liquid and gases breakdown. So let me get into more about it. Like if we are having the air insulation, air as an insulation, then if the breakdown occurs, it is called as the self-storing type of insulation. Means the breakdown of the air will occur, but again it will attain its dielectric strength. If we discuss about the liquid insulation, then in case of the liquid insulation, let's say transformer oil, if the breakdown occurs, then some discharge will occur within the transformer oil, and it will get deionized, and it is the possibility that it can degrade its dielectric strength, but we can reuse it again and again. But in case of the solid dielectric sample, we can't use it again. It will get damaged and it can't be reused. And the flashover test is very common. If we are having an insulating unit, and then we are doing the we are doing the breakdown test in the air. So there will be a discharge that will occur in between the high voltage electrode and the ground electrode. So that breakdown of air is actually a flashover or the discharge which is taking place from the high voltage electrode to the ground electrode. So I have categorized the breakdown of flashover test firstly for the alternating voltages. Under this category, first comes a withstand voltage test. So what we do in this, we apply the voltage to the test object at a value which is which is sufficient to prevent any effect of over voltage. Actually, while doing these withstand voltage tests, we should keep two things in mind. Like when we are switching on the voltage and we are reducing the voltage, there should not be any sudden phenomena. Otherwise, there will be erroneous results. Maybe some switching transients will occur, and we may wrongly read the data for the alternative voltage instead of the switching. We may read the data for the switching over voltages instead of the alternating voltage. Then, therefore, this thing should be kept in the mind. And these tests are carried for the 60 seconds. That is for the 1 second. So for 1 minute, that is, if for that 1 minute, if it sustains that voltage, means the insulating unit has passed the withstand voltage. So this is means there is no disruptive discharge which is occurring within that 1 minute. After that comes the disruptive discharge voltage test. It's the same thing. We apply the voltage to the test object and we'll raise it, and we'll keep in mind that it should not be a certain over voltage so that we don't have any switching over voltages there. And it is also applied for the 60 seconds, that is for the 1 minute. And if the disruptive discharge occur, it means that it doesn't pass the withstand voltage, and we call it as the disruptive discharge voltage. But these disruptive discharge voltages are subjected to the statistical variations. So in the further slide, I have given some scope to define this statistical variation. What are the statistical variation? Actually, if I take one example, like if we are having 10 samples, then there is a probability that the first of the sample may fail at 100 hours. If we are doing the aging testing. But the 10th of the sample may fail at 1,000 of hours. So why is it happening? It is a very abnormal thing. Like we can't predict the breakdown voltage for all these 10 samples. Therefore, we need to do the statistical variations. Under the statistical variation, I have three things. There's a statistical distribution, censoring, and the variable distribution. Actually, the statistical variation can be done according to the probability distribution or according to some equation that we call as the best fit. So firstly, I'll go to the statistical distribution. In the case of the statistical distribution, it is also called as the normal distribution or the Gaussian distribution. What we do, we are having a number of samples. So we calculate the average value of the breakdown for those number of samples and the standard deviation. Actually, we can't get the infinite number of specimens. We can get the only finite number of specimens. So as these estimate, that is the average value x bar and the standard deviation s, may differ from the mean value and the standard deviation. So how we define the mean value? It is the most probable outcome. That is the most probable value of that breakdown voltage. And the standard deviation is the measure of the amount of variation possible around this mean value. So when we are doing this statistical distribution, we can't say that this mean mu is the exact value. So we are having it as confidence interval. What is that confidence interval? We are saying that for this particular mean value, there is some range in which the breakdown probability of that particular specimen would be lying. So for that we define it for that we define the confidence interval. And as I told that the statistical distribution are actually the Gaussian distributions. So we can define the Gaussian distribution according to this formula. And then we calculate our as we have calculated our mu and we have calculated our sigma, so we can calculate it. We can calculate the probability of the breakdown of the particular insulation unit. So the next thing comes the censoring. Actually, if we are doing the testing for the 10 samples, then it may occur that for 9 of the samples the breakdown occurs or the flashover occurs, but for the 10th sample it doesn't occur. So it's very difficult and it may occur after a very long time. So it's a very tedious task to wait for that particular 10 samples to calculate the mean mu and the standard deviation. So what can be done is like we don't wait for the particular 10 sample, we just censor it. So that's why censoring is like when an experiment is performed and the parameters are needed to be estimated, but that particular number of samples have not been failed. So we define some time period that till this time period we will wait. If it doesn't wait, we'll censor this particular specimen and we'll estimate the mean value and the standard deviation for the rest of the samples which have been failed. Then according to that we'll calculate our breakdown voltage probability. Next comes a viable distribution. It's very common type of distribution. It is employed in experiment in which the breakdown voltage insulation is measured, and it is actually it is called as the weak link phenomena. Actually, it doesn't represent the health of the complete insulation. If while I am doing some experiment, if there is some defect in my insulating material due to the contamination or due to some voids or due to the reason that if we are making the sample, it can't be thin throughout. It can't be uniform throughout. There may be a possibility that the sample is thin at some point and thick at another point. So due to that weak link, the breakdown occur. So the probability of the breakdown in that case can be defined using the viable distribution. Viable distribution has two parameters, that is the alpha and the beta. Alpha is called as the scale parameter. Actually, it tells about the uh, time by which the failure is occurring, and beta is the spread parameter, which actually tells about the range of the data. So this is one example which I have taken to test how we test the objects under the AC voltage. So this is my test device which I have used. This is a transformer. So this transformer, as Dr. Alok Verma has already discussed about this, we just need to step up the voltage through this transformer, and we observe the occurrence of the breakdown of this test device. And this 200 kilo ohm this resistor is connected just to make a transformer safe if a breakdown occurs in the test device. So next are the tests for the direct voltages. These are also the similar to the AC voltage test. We have the resistance voltage test. We apply the over voltages for around 60 seconds. That is the 1 minute. And then it also depends upon the test requirement. And other things are like it depends upon the test requirement for any particular apparatus also. Like for how much time we need to apply the voltage. I have given the general overview. So it depends upon like if we are using cable if we are using transformer. So what is our requirement? According to that, we can apply the over voltage. Also, in this case, in the DC voltage, we actually keep the mind that the polarity of the voltage or the order in which the voltage of each polarity are applied. That will also be kept into mind while doing this resistance voltage test. So if for a particular 60 seconds,
So, ma'am, we can't hear you.
I think think her connection is disconnected.
No, she's.
Somebody please call her. Okay, she'll come back. I'm sorry, we are just trying to get her back on.
Sorry for the interruption. I had some problem with my internet connection. So we were talking about the disruptive. We talked about the withstand voltage test for the direct voltage, and after that the disruptive discharge voltage test for the this high voltage equipments with DC. So the again in the same way as we did for the high voltage AC, the voltage is applied and raised as specified by the relevant apparatus standard, and then for this the value of the test voltage, which is before the disruptive discharge will be recorded, and if so it means if the disruptive discharge occurs means that that particular insulation unit is not good enough to be used. Next, the test for the impulse voltages. So firstly, it comes the 50% disruptive discharge voltage test. As the most frequently occurring over voltage in the electrical systems are generated from the lightning and the switching over voltages. So these are the tests which I am going to discuss are the basically laboratory tests. So I can categorize into three: multi-level method, up and down method, and the extended up and down method. So firstly, we'll discuss the multi-level method. In the case of the multi-level method, we select the several test voltages. Then we apply the pre-specified number of shots at each voltage level. After that, we count the number of breakdown. Let's say if I am having for a particular voltage level, if I am having a 10 number of shots, then I'll count the number of breakdown for these shots. Like let's say 6 times breakdown occur out of these 10 shots. After that, the probability for this breakdown voltage will be will be calculated, and then we'll plot the probability distribution function for this particular breakdown voltage against the all voltage levels. After that, we'll draw a best fit line on the probability scale, and then we'll calculate the 50% that the critical flashover voltage, which is like V50, and then we'll calculate our mu, and then after that, we'll calculate the standard deviation. So in this way, this multi-level method, we compute the impulse voltages for the breakdown. Next, the up and down method. In the case of the up and down method, what we do, we just start with some particular voltage which is in the close proximity of the flashover anticipated flashover voltage. After that, we'll select a delta V. Delta V, let's say, if I am selecting the voltage as 10 kV, then delta V will be maybe 9 kV or the 11 kV. So after that, I'll apply one shot at that VI, let's say at 10 kV. So for that particular at VI, if the breakdown occurs, then it means that it is not able to sustain that 10 kV. So what we'll do, we'll apply the Vi minus delta V. Let's say this delta V is 1 kV, so we'll apply the 9 kV against the 10 kV. So if it sustains that voltage, then we'll go to this again, we'll apply the short for next Vi. But let's say if after applying the Vi, it withstands that voltage, that is 10 kV, then we'll apply for the Vi plus 10V, means 10 plus 1 kV, means 11 kV. And the same procedure will be followed. And there is one more thing, that this up and down method is used for the insulation which are having a self-restoring capability. So in the pictorial diagram, the same thing is shown, that we are applying this X means breakdown, and this circular thing represents the withstand thing. So if a breakdown is occurring, we'll come to the lower level. Then we'll again, if it sustains that voltage, we'll up the voltage, and then we'll again check for the breakdown. Again it sustains, then we'll again up the voltage, and then we'll see the breakdown probability. If the breakdown occurs, then it will come down. So in this way, it is in this way we do the up and down method for the impulse voltages. Next is the extended up and down method. So in the extended up and down method, we select some number of shots. Let's say if I am having a 940 kV, then this voltage is increasing from 940 to, let's say, 1060 voltage. So firstly, we'll apply a shot at 940 kV. Out of 7 shots, there is a if that specimen sustains all the shots, means there is no breakdown, means there is zero breakdown, then the voltage will be raised. Let's say 970. So again, there is no breakdown, there is zero breakdown for these 7 number shots. It will be again raised, again raised. So in this way, it will be raised. Let's say for if I am applying the first shot, in that first shot the breakdown occurs, then it will be the voltage will go down, and then we'll apply the second shot. If it again fails, then we'll again go down, and then we'll apply the shot. So in this way, this extended up and down method, we do the testing for the impulse voltage, and this is again for the self-restoring insulations. So the withstand voltage for the impulse voltage, there are several procedures according to the IEEE standards. Like if we apply the C impulses of the specified shape and polarity at the rated withstand voltage level to the particular test object, and if there is no indication of failure, means that it has satisfied the withstand voltage. Next, it can be like 50 pulses of the specified shape and polarity at the rated withstand voltage level are applied to the test object. And if the test is, if there is no more than 2 disruptive discharges occur in the restoring part of the insulation, and if there is no indication of failure in the non-self-restoring insulation, then we say that the particular specimen for the impulse voltages withstand the withstand that particular impulse voltage. Next is the solid dielectric breakdown test. This is this test we have carried out in our own lab. So this is the high voltage transformer. This is our coupling capacitor, and we have used the solid breakdown sample within this transformer oil. The reason behind the, as I have already explained in the earlier slide, that the if I don't use the transformer oil, there is a possibility of the air breakdown instead of the solid dielectric breakdown. That's why we immerse the solid breakdown sample into this transformer oil. So we apply the several test voltages, and then we see at what voltage the breakdown of the solid dielectric sample occurs. And there is one thing we can't say, just doing the 1 or 2 samples, we can't say that, oh, okay, this is a particular breakdown voltage which is for this polymeric sample, of which is for particular sample. We need to do at least 25. We need to do the test for at least 25 samples to reach to a particular conclusion for this breakdown. And I have told that already that it's like a probability distribution type of thing. Therefore, we need to do the viable distribution for this to calculate the probability of the particular breakdown voltage. And then we use this equation that I have already discussed. Next is the test on the transformer. So in the case of the test on transformer, what we do, we apply a impulse wave to the transformer with 75% of magnitude. If there is no failure occur, then we again raise the voltage to 100% voltage. After that, if there is no breakdown which is occurring, then again we'll apply the voltage to 115%. So this is a chopped impulse wave. So you can see that after applying a certain magnitude of the impulse wave, after a certain time, it comes down. So we at this point we can't say whether some damage of the insulation has been occurred or not. Therefore, to ensure this thing again, voltage with 100% amplitude is applied to the transformer, and then we compare this wave with the initial wave when there was no breakdown. If there is a difference in between these two waves, then we say that the damage of the insulation has been occurred. Otherwise, there is no damage of the insulation. Next is the test on the overhead insulator. We can categorize into three parts like 50% dry impulse flashover test, the dry flashover and dry 1 minute test, and the wet flashover and 1 minute rain test. So what is the 50% dry impulse flashover test like? Will apply the 50% of the magnitude of the impulse voltage to the insulator unit, and if it's let's say 1 minute, if it sustains that voltage, then we say okay, it has passed that impulse voltage. Otherwise, the insulator unit will get damaged. Then is the dry flashover and the dry 1 minute test. In the dry flashover and dry 1 minute test, the will apply the particular impulse voltage for 1 minute, and then we'll see whether the insulation gets fail or not. If it does fail, that we'll say that the okay, insulation is not of good quality and it has been failed. Otherwise, otherwise it will sustain that particular voltage. In the wet flashover and the 1 minute rain test, we apply some artificial rain on the insulator unit. Then after that, we'll observe the insulation failure, whether it fails or whether it sustains that particular voltage. So this is all about my presentation. Thank you for your attention.
So if anyone has questions, please share the question in the Q&A or raise your hand. Yeah, Nitin Jha, I will allow you to talk. Okay, Nitin, you can ask the question by unmuting yourself.
Yeah, in case of a up and down method, if suppose a dielectric is behaving in an erratic manner, means for some impulse it is passing and for some impulse it is failing at the same value, then what should be the interpretation?
Okay, like as I already told that this up and down method and the extended up and down method, these both are called the self-restoring type of insulation. That is one thing. Okay. So we do all these type of testing for large number of samples. So as I have already told in my initial slides, that if some of the specimen gets filled and some of the specimen doesn't get filled, we need to do some type of distribution. That is one of the distribution that I have discussed, is the viable distribution. And then according to that, we estimate our breakdown probability.
So in viable, how much percentage acceptance is recommended?
How much percentage means?
In viable distribution, how much area of acceptance is accepted, means in sigma level?
The confidence interval you're talking about.
Correct, confidence level.
That 95% confidence interval is accepted.
Okay, thanks.
Yeah.
And then I have Ritanjali Beda. You can ask the question.
Hello, ma'am. Hello. Good afternoon, ma'am.
Good afternoon.
Can you hear me? Hello.
Yeah.
Yeah, good afternoon, ma'am. Ma'am, in withstand test, both in AC and DC, you are keeping time for testing time 1 minute. Is it standard or can I change the time period above 1 minute? Hello.
Okay. Actually, I have told this thing also. Like this presentation was a very general presentation. I have not concentrated on particular apparatus. So according to the requirements of the manufacturer and the customer, we can increase this time. But as a general IEEE standards, it is for 1 minute.
Okay, ma'am.
So Modi, you can ask.
Okay, thank you, ma'am.
Hello, is it audible?
Yeah.
Good afternoon, ma'am.
Good afternoon.
Actually, I want to know what is the basic difference between the withstand voltage test and the disruptive test?
Okay, withstand voltage means like whether you're in the case of the withstand voltage, we don't wait to get your insulation unit to be damaged. Like if I am saying that I am applying particular voltage for 1 minute, if it sustains that voltage, I am saying that let's say 10, if I am applying 10 kV for a insulating unit, if it sustains that 10 kV, I am saying that it can withstand that particular 10 kV. But if it fails, means that that is the disruptive discharge voltage for that particular unit. Is it okay? Or
Yes,
If
yes,
I
ma'am.
may add here, Asha, I think the basic difference is what you have said is absolutely correct. I think the basic difference is what are we trying to measure? So when we do this breakdown test, there are two things that we might be wanting to measure. As we are all aware, the breakdown voltage or the withstand voltage depends upon two factors. One is the stress level, and the second is the time duration of application of voltage. So when we are doing a withstand test, what we are doing is we are fixing the value that we want to test for. So we would like to see whether air can I'm just giving an example. Air is going to withstand 30 kV per centimeter. And then we will say that we will perform this test for X number of minutes. And if for X number of minutes, the material has not failed, that is the testing parameter. Whereas in case of disruptive voltage, what we are seeking is the voltage. We are trying to find the voltage at which the breakdown occurs. So when you draw the probability distribution curve, in one case, voltage would be your random variable, in the other case, time would be your random variable. Though we are looking at the same physical process, we are characterizing them in two different ways. So I would say probably that is the significant difference when in books you see people talking about disruptive voltage and you see people talking about withstand tests.
Okay, ma'am. Thank you.
So Nitin, I think you have one more question. So yeah, you can ask. Nitin?
You have a question from Raju Midya. The questions, yeah.
Sorry, my net was slow.
Okay,
Actually,
this is Nitin.
I
right?
that is Nitin.
Yeah,
Yes.
Nitin Jha.
Okay.
Yeah. Actually, I want to configure air gap for a particular 145 kV class. So in that case, I conducted the 50% breakdown level. But this exercise, but what happens, the shape of the electrode also changes in some flashover. So how I can take care of that thing also, that material should not melt in that condition and it should be stable at that particular point.
If you are saying in the shape of the electrodes change, that the
shape in a sense is, if suppose flashover has happened, so pitting mark will come, so that will distort the field distribution, correct? So the breakdown voltage at that will not be at the same value, it will be a reduced, because the sharp point will come.
You will have to change your electrodes. There is no other way.
Exactly, because now in the
No
case
other
of the when you are using the spare gaps or something like that, we actually have to have the uniform electric field distribution. If there is some sharp edges, then automatically it will not be the breakdown of that particular sample. It will be the flashover of that sample through the edges of that electrodes.
Okay, so some hard coating should be done onto the electrode material.
That you should take care. Yeah.
Oh, okay, thanks.
Or change the electrodes after every shot if that is an option.
But ma'am, in case of a product, we cannot.
I know.
We have to give a product like that.
No,
it
you
should
cannot do
withstand
that.
the voltage.
No,
Yeah.
You cannot do that. You have to prevent that then.
Is it the at the edges that polishing is getting degraded, or within the center, or what?
At the tip where the flashover has happened there.
Okay.
In the question answer, there was a question from Raju Midya.
Yeah, Raju, you can ask the question.
Hello, ma'am. Good afternoon, ma'am.
Good afternoon.
And what is the basic difference between puncture and flashover in insulator?
Okay, puncture means like breakdown of that particular insulation unit, whereas flashover means the surface discharge. It is not taking the path through a solid material of that particular insulating unit. It is taking the air as a path from the from the high voltage electrode to the ground electrode. So it is actually not the breakdown of that insulation, it is the breakdown of the air, the flashover.
Yeah, Raju, you will see these two experiments in the next session. We will perform both flashover and puncture.
Okay,
That can be explained that how the air breakdown is occurring.
Thank you.
So, any more question? I guess no. So thank you, Asha ma'am, for your talk.
Thank you, Kingshuk.
Yeah, and we will meet after, we will meet at 3:30 for the lab demonstration of some of the experiments we have discussed in the first half, and it will be performed by Himanshu Gupta. So we will all be back at 3:30. Okay.